Hi everyone, my name is Madison Smith and this is my Lab 3 presentation. So for the introduction, the purpose of this lab is to measure the distance dependence of a magnetic field using a bar magnet. So we calculated the on and off axis measurements for the magnetic field at different locations, and then the coding portion compares the measured data with the magnetic field that we calculated at a 45-degree angle at a certain distance away. So some key principles that I wanted to highlight were the Biot-Savart law. So you can calculate the magnetic field, in our case, due to a bar magnet. And so the on-axis calculation for the magnetic field is mu naught over 4 pi times 2 mu over r cubed, where mu is the magnetic dipole due to that magnet and r is the distance away from the magnet to the observation location. So the first part of the lab was to measure the distance from the sensor on my phone to the magnet, where the magnetic field magnitude was at very specific different values. And so we calculated the distances, and then we plotted the natural log of the magnetic field versus the natural log of the distance away. And so we used these measurements to calculate the distance dependence in and the magnetic dipole moment mu. So calculating the distance dependence, so we knew that the natural log of k was going to be equal to the intercept of the line, so we used this to calculate k. And then the magnitude of the magnetic field was 6.2 mu Tesla when the x component was 0, and that distance was at 0.0485 meters. And so we put all of those together and calculated for n, which is negative 4.875. And then we calculated the magnetic dipole moment mu, where the natural log of k again is negative 10.62. And so we used that value to calculate mu, which was 12.2 joules per Tesla. So the second part of the lab was to measure the perpendicular distance away from the magnet, where the magnetic field magnitude was equal to 100, and the x components canceled out, so that distance was about 0.0223 meters. And so we calculated the distance away using the Pythagorean theorem to the observation location at a 45-degree angle away from the magnet. This is a little representation of what exactly we did with our measurements, where we calculated the perpendicular values and then use the Pythagorean theorem to solve for D. So to kind of go through my code, so to start in the top left corner, we made a function for the magnetic field due to the magnetic dipole. And so we did that, and then going over to the right side, we calculated the observation location at different distances away from the magnet on the axis. And then going down to the bottom left corner, we calculated very similarly to the top right, but these observation locations are on the perpendicular axis to the magnet. And then the bottom right corner was calculating the magnetic field at the 45-degree angle, very similar to what we did on the last slide and what we calculated in the lab. So we have the many different observation locations to calculate the magnetic field due to the magnet. So this is what I ended up with for my final representation. So we have at the top the magnetic field on the axis, on the perpendicular axis, and then at a 45-degree angle, a distance d away, which is 0.31537. And so the orange represents the on-axis, the blue is the perpendicular, and the green is the 45-degree angle. All at these different observation locations. And so some questions that I wanted to answer. So what if we hadn't oriented our experiment to compensate for the magnetic north and instead of laid out our meter stick at some random angle? And so it would not have been as accurate. I actually had to go through this a couple times and finding a surface that was correct and being able to measure this so it was calibrated. And if not, then your numbers are going to be very off and not going to be as accurate. And so if you were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? And so our measurements would double. So the magnetic field at an observation location with the two magnets put together would be double in magnitude in the same direction. So thank you for listening, and let me know if you have any questions.